visible?
Yes, Jitin, please go ahead.
Okay. Uh, mm, I am Jidin from PLM Industech, and me and my colleague Mr. Ajay Balakrishnan will walk you through uh, the process of virtual commissioning in Process Simulate. Uh, let's have a look into what VC is. As you all know, commissioning is the last engineering step in the process of building a production line. You all know that after planning, then designing and engineering phase, and once all the equipments and machineries are installed on the shop floor, the commissioning phase begins. Nowadays, simulation softwares allows us to design, test, and commission virtual model of production line before you install it on a shop floor. This process is called virtual commissioning, and Process Simulate is a powerful tool for virtual commissioning. Virtual commissioning includes building a full simulation model of the production line, which is also known as the digital twin. Digital twin enables the connectivity to real control system so that the manufacturers can test, debug, and validate control logics and robot programs in parallel with other engineering phases. Virtual commissioning with Process Simulate provides the solution which allow us to complete much of the work in virtual world, thus cut short much of the commissioning process in the field. Timeline can be drastically reduced, which saves time and money. Moving on to the uh, next topic. Uh, Now, coming to the key differences between traditional commissioning and virtual commissioning. Uh, in traditional commissioning, all of the PLC logic and robot program must be validated in the shop floor. In most of the cases, programmer must wait for the installation to complete for starting the validation of PLC logics. I believe most of you guys have experienced this in shop floor. You might have rescheduled your commissioning plans due to the delays in installation of equipments. Again, in the case of robot programming, one must wait to complete installation even to start the teaching. On the other hand, most of the PLC logics can be tested and validated offline and ready to upload robot programs, which is called as OLPs, can be downloaded from Process Simulate. Again, a lot of dry runs and part trials needs to be taken to ensure the system behaves in the intended way. And in fact, resetting the system to initial state is a tedious task on shop floor. Imagine moving parts from fixture to fixture or adjusting the sensor positions on the field. Those who guys worked on commissioning phase must have experienced this, right? Uh, you know, once you start running the system, you may find some bugs in the code, like the conveyor is not starting or stopping as you intended. Then you have to start all the process once again, uh, which is a really time consuming process. In case of virtual commissioning, resetting the system to the initial state is just one button click away. Imagine how cool that is, right? Again, moving on. Here is a graphics that highlights traditional commissioning and virtual commissioning. Moving forward, let's have a look into the Process Simulate virtual commissioning workflow. Here, Process Simulate offers multiple tools and options apart from the normal modeling platforms to enable build a complete production digital twin. Speaking of building virtual commission environment, once you get the final 3D model from the mechanical team with all the kinematics done and the robot programs, teaching and path planning, etc. has completed, we have to make the cell alive so that it can communicate with the control software such as PLC, DCS or SCADA, etc. We have specific tools and options to do this in Process Simulate, such as tools for creating sensors, conveyors, and appearances, etc. As we move forward, we will see about this in detail. Moving forward, It is important to create accurate and functional model of various systems and equipments to do VC. Guess what? We have option to build logic behaviors of different systems such as VFDs or servos, pneumatic and electrical actuators, weld controllers, etc. Next one is one of the integral part of virtual commissioning, which is interfacing the digital twin with the control software or logic. Process simulate supports cross-platform connectivity with the help of multiple connection methods like OPC and PLC sim advanced, etc. With all this done, how do we validate the process? Process Simulate has multiple tools such as signal monitoring, simulation panel, and simulation monitor to accomplish these tasks. Here is a graphic showing various elements in virtual commissioning workflow. Now, referring back to the building of virtual commissioning environment, we all know that feedback is a critical part of any automated production process. Different types of sensors might be required to develop complex production systems. Process Simulate have built-in functions to create and use different types of sensors, such as photoelectric sensors, proximity sensors, etc., which you may all familiar with. These can These can be used to detect presence of parts or any other mechanical elements in the production system. Similarly, we have some special sensors like joint distance sensor, which can be used to measure distance moved by any axis in a kinematic system. For example, you may have to find the exact position of a slide which has moved a certain distance. Well, joint distance sensor can do that for you. Furthermore, we have joint value sensors which triggers at a different mechanical process created in a kinematic system. For example, it can be used to accurately detect the advance and return positions of pneumatic actuator or opening and closing positions of a valve, like reed switch or limit switches installed on physical world. The applications are limitless. Moving on, material transportation might be challenging as well as a complex task in many of the production systems. Process Simulate has powerful tools to model and validate different kinds of conveyor systems. Once we define a component as a conceptual conveyor, we can transport parts or skids, which is essentially the ones which carries parts on them, along a predefined 3D curve. Different types of conveyors model can be created and simulated inside Process Simulate, such as belt conveyors and roller conveyors, which carries parts on them, and chain conveyors, which carries skids. Built-in features like control points allow us to create stopper points, uh, which is very common in any real conveyor systems. And we have the options for orientation change of the parts and speed change points. All this will bring close the digital twin model to reality. Moving on. Here is a demo video where you can see sensors and conveyor in action. You can see we have the options to start, stop, and stop the conveyor. Also possible to change the direction. You can see once the sensor is sensed, the stopper is activated. Then the operator can load or unload the part to the conveyor. And once he acknowledges the action, the stopper will be released so that the skid can move in its way. Moving on. Material flow. Material flow is the description of transportation of parts during simulation. In the assembly line, we will have multiple child parts which will be transported through different stations for performing operation on them. And in some stations, they will be assembled together. In Process Simulate, we have Material Flow Viewer to design and edit and control the material flow through the different stations. Part appearance can be created automatically during simulation. Here in this example on the right side, you can see that multiple part appearances have been created instead of copying and pasting the part itself. Moving on, looking back into Process Simulate virtual commissioning workflow, we have logic building section. So logic blocks are logic blocks and resources are powerful options available in Process Simulate to build behavioral models of various devices and equipments. It contains a defined logical behavior which is derived from specified inputs and outputs in an equation or formula. The elements of logic block includes entries, exits, parameters, and constants. Through entries and exits, logic blocks can be interfaced with PLC and other logic blocks. Built-in functions allow us to perform Boolean and arithmetical operations as well as graphical operations. Application examples include evaluation of logical expression in different systems and various types of feedback systems. For example, you may have to develop some systems which will produce dynamic outputs depending on the inputs received. Like weld controllers in a robotic welding system, where it should communicate and update status to robot and PLC based on the commands received from PLC. Uh, you can do this using logic blocks by writing proper logical and arithmetic expressions. Another examples where LVs are commonly used to update the status of devices and equipments to the PLC, like the status of air pressure, temperature, or whether the conductor is turned on or off, etc. The kind of things that you will commonly see in the field. Moving on, we have smart components in Process Simulate. So smart components has capabilities to perform actions upon receiving inputs in accordance with logic it contains. It is a combination of logic and kinematic behavior. In other words, smart components act as a device with a built-in logic which can perform its actions based on the instruction received from a master like PLC. With the Process Simulate, any system or device with kinematics can be converted into smart components. Here you can see a slider has been converted into smart component so that it can advance and return based on the input received from the PLC and update its position status back to PLC. We will see this in action in upcoming slides. SCL editor. So SCL editor is based on TAA Portal's version of structured control language. It allows to program in high level language. It has all the functionalities of logic blocks and smart components. In fact, we can consider SCL editor as a successor of logic blocks. As you know, most of the control engineers are familiar with the high level languages. What I personally like about SCL editor is that it supports evaluation of conditional statements such as if else statements, for loops and while loops, which enable us to create complex logics without trouble. Another big plus point of SCL editor is that it helps us to interface FMUs, which is functional mockup units, to Process Simulate, so that complex drive models can be simulated inside Process Simulate. The block interface allows us to connect SCL block with other logic resources and external signals. Moving on. Here is the video where material flow, sensors, conveyors, logic blocks, and SCL in action. Here slides are defined as smart components. Logic blocks and SCL editor controls the material flow, conveyors, and the slides based on the feedback getting from sensors and smart components. You can see signals are interfaced to the controller and exchanging status each other on the left side. moving on. As I mentioned before, behavioral models are essential part of any virtual commissioning system. An accurate behavioral model of field device or equipment are necessary to test and validate a production system and control logics as process logic demands it. Here is an example. You can see a servo controlled linear accelerator has been set up in the process simulate. In TA portal, servo drive and motor has been configured with the technology object, and the profit drive communication to the drive has been configured with the Telegram 3. The control logics has been developed using standard motion blocks, and the HMI is programmed for operator interface. As you can see, operator can control the slide by pressing buttons on HMI, like on the shop floor. He can change the position, velocity, etc. And the operator can operate the slide in different modes like relative and absolute positioning. You can see the status is being updated on the process simulate signal viewer as well. Here, logic block and SCL editor plays their role so that drive functional mockup units can be brought into the PS so that we can build efficient behavioral models. In conclusion, this is one of the beautiful example of how process simulate can bring life to your work cell or production line using built-in powerful tools and functions so that you can validate your process logics and confidently go to the shop floor for commissioning. Uh, my part ends here. My colleague Mr. Ajay Balakrishnan will lead you through the next topics in VC workflow. So over to you, Ajay.